Hello everyone, welcome back to the learning field. So in this video we are going to discuss the questions of CSIR-NET June 2023. The questions are from partial differential equations. Okay, so here in the paper I think 4 questions comes. Okay, so 2 questions are of 3 marks and 2 questions are of 4.75 marks. Okay, so here in this video we are going to solve the complete partial differential equations questions paper of CSIR-NET December 2023. Okay, so there are first the question is 704043. This is the question ID and this is a 3 marks question, and this question is from the classification of PD. Okay, so the question says that the following PD, this x square del 2x del y 2 minus 2xy del 2 del x del y minus 3y square del u del 2 del y 2 plus these two elliptic, parabolic, hyperbolic and parabolic in the region are given. Okay, so if we write this equations is the standard form, then it is r I think r into capital R into u x x plus s u x y plus t u y y plus function of x y u p q. This is equal to 0. If we write the standard forms, then we know, or we have to find just the value of s square minus 4 r t. If this is greater than 0, you all know this is hyperbolic. If this is less than 0, then we know that this is elliptic, and if it is equal to 0, this is equal to 0, then this is parabolic in the given region based on the region. Okay, now we calculate the s square minus 4 rt term. So this is equal to, so here what, r equal to x square, s equal to minus 2xy and t equal to minus 3y square. If we compare these two equations, the given equation and this equation. Okay, so this is equal to minus 2xy whole square minus 4 r means x square and y square means here minus 3y square. Okay, so this is equal to 4x square y square plus 12 x square y square. So this is equal to 16 x square y square. Okay, now if option A says that it is elliptic in the region for only y greater than 0, but if only y greater than 0 and x equal to 0, then s square, this term goes to 0. Therefore this option is not right. Parabolic in the region x greater than 0, y greater than 0. No, if x and y both are greater than 0, then this s square term is obviously positive. So this is also incorrect. Then hyperbolic if xy not equal to 0. Okay, this is fine. If xy not equal to 0, then x square y square also not equal to 0, and 16 x square y square is non-zero. That means this option is correct one, and it is parabolic in the this region. But if xy not equal to 0, then we get already that this is hyperbolic. Okay, again you can say that this is a 3 marks question and only one option is correct. Therefore option C is our correct answer. The next problem is question number 704044. Okay, I just write the original questions. Okay, now the question says that, I read once the question. The question says that consider the Cauchy PD. This is a Cauchy PD. Consider the Cauchy problem of wave equation del 2 del x del minus 4 del 2 del x is equal to 0 and u x0 equal to this one, it is equal to minus 1 by x square, x not equal to 0, and del u del dx0 equal to x e to the power minus x square. So these are basically the functions of fx and gx which we use in the solution of the wave equation if we solve using this with D'Alembert solution. Okay, so you can use, but see, this function is some kind of different types of function given in these questions. Okay, but no way, चलो कुछ नहीं करते start. Okay, so देखो, if we write the D'Alembert solution, then we all know that uxt, this is equal to half into f of x plus ct plus f of x minus ct. If the standard problems is of the form utt, this is equal to c square uxx. Okay, so here c value is 4, c square value is 4, this implies c equal to 2. So now this is the problem for only for this, but here we see that this gx term is also present in this problem. Okay, so how can we solve this problem? for this non-homogeneous solution, for if we use this function is used, then this is equal to, we know that 1 by 2c integration x minus ct to x plus ct into gs ds for this function, if we take this function as g. Okay, now so this equal to u of xt, this is equal to half of, if we write f function is this one. Okay, this is the f function and this is the g function. So for x not equal to 0, if x equal to 0, then this function is going to 0, but here all four options are u5t, that is the value of x should be 5 in this whole question. So this x 0 is not possible in any case, therefore x is not equal to 0, therefore we use this function for x not equal to 0, and here also present in the options that x equal to 5 here. Okay, so if you write u5t, then this is equal to f half of f of x means 5 and c means 2, so 5 plus 2t plus f of 5 minus 2t plus 1 by c value is 2, so 1 by 4 integration 5 minus 2t by into 2 5 plus 2t, and gs ds means this function, so as e to the power minus s square into ts. Okay, so this is our complete solution. Now if we integrate or if we write the value of this function, so this is equal to f of 5 plus 2t means half of e to the power minus 1 by 5 plus 2t whole square plus e to the power minus 1 by 5 minus 2t whole square. Okay, I think I am writing the correct one. Yeah, so plus 1 by 4 integration, if we multiply by this 2 here and then write 5 minus 2t to 5 plus 2t into 2s e to the power minus s square ds. Now if we write this s square is equal to t, then 2s ds is equal to dt. That's why I multiply by 2 in the numerator and denominator term. Okay, so this is equal to, this is fixed, 1 by 2 into this term plus 1 by 8 into e to the power minus s square. Okay, so see only e to the power minus s square, 5 minus 2t to 5 plus 2t. So this is final comes half e to the power minus 1 by 5 plus 2t whole square plus e to the power minus 1 by 5 minus 2t whole square plus this is plus 1 by 8 into what is present e to the power minus of 5 minus plus 2t whole square minus e to the power minus 5 minus 2t whole square. Okay, so this is the complete solution. Now if we take limit as t tends to infinity, therefore this term goes to 0, that is limit t tends to infinity u of 5t, this is equal to, so see this is half, and if we take limit then this term goes to e to the power minus this, that means e to the power minus 1 by this means this term goes to 0, see 1 by 5 plus 2t, okay, or 5 minus 2t, this term goes to 0, as 5 plus 2t tends to infinity, 1 by that infinity tends to 0, that means e to the power 0 plus e to the power 0, again this term goes through again 0 plus 1 by 8 into e to the power minus this term. Okay, this term goes to only 1 and minus 1. Okay, e to the power minus this means this term goes to 0, that means e to the power 0 means 1 minus 1, that means this term completely goes to 0. So half into 1 plus 1 plus 0, so this is equal to only 1. So the correct answer is here option 1. Okay, that is, this is the correct answer. Now goes to the next problem, and next problem is a 4.75 marks question, and question ID is, okay, I just write the question and ID. The question ID is, just a minute, this is 704094, 704094. Okay, the question says that consider the Cauchy problem u del x plus del u del y is equal to 1. Xy belongs to R cross 0 infinity. U x0 equal to kx. U x0 this is equal to kx. Okay, with the given real parameter k, for which of the following values of k does the above problem have a solution defined on R to 0 infinity? Okay, the four options are k equal to 0. The option 2 is k equal to -2. Option 3 is k equal to 4. Option 4 is k equal to 1. Okay, so this is a problem. So this is I think you all know that the what is the solution procedure of these types of problem or Cauchy problem. First we have to take the Lagrange solution. Okay, so take the Lagrange solution. Okay, so dx by what? Dx by u equal to dy by 1 equal to du by 1. Okay, now if we take the second two, that is second two ratios, then dy equal to du. This implies u minus y equal to constant c1. Okay, and if we take the u square, okay, if we take the first and the last, that is dx is equal to u du. So this is equal to u square by 2. This is equal to 2x, sorry, x plus c star. Suppose this implies u square is equal to 2x plus c. Okay, so this is the complete c2, right here the c2. Now if we write c2 equal to phi of c1, the solution. Okay, so this implies c2 means what? c2 means u square minus 2x. This is equal to phi of u minus y. Now we use the initial condition u x0 equal to 2x. Okay, so what u x0 equal to 2x? U square. U square means this is k square x square minus 2x. 2x terms present, then phi of u means kx minus y equal to 0. So this is phi of kx. So kx means this one, that is phi. If we represent replace this kx, this is equal to u, then what happened? So k phi u, this is equal to u square minus x means u by k, means 2 into u by k. This terms comes. Okay, so now write the solution. So the solution is what? This u square minus 2x is equal to u square minus 2x. This is equal to phi of kx. Now again we write k. So phi of kx means what? If we put phi of kx, then this is u square means k x square. So k square x square minus 2 into x only. K square x square minus kx. Just a minute. U square minus square equal to u minus y. Okay, phi of u minus y, right? So this is equal to u minus y whole square, u minus y whole square, and minus 2 by k into u minus y. I think this is the correct one. Yes. So this is equal to, now if we find minus 2x plus u square, this is equal to u square minus 2uy plus y square minus 2k into u minus plus 2y square, 2y by k. Okay, now u square cancel from both sides. Now we collect the u one side and the other terms on the remaining side. Now if we calculate here the k, so u, so this is equal to u into minus 2y and y minus 2u into y plus 1 by minus u common y plus 1 by k, I think y plus 1 by k, yes, and in this side minus 2x plus minus 2y by k. Okay, so this implies minus minus goes from both sides, so 2xk plus 2y by k, this is equal to 2u into yk plus 1 by k. So this implies k goes from both sides. So u is equal to actually what? xk plus y by yk plus 1. Okay, this is the value of u, I think. Now, okay, correct. Next, what will happen? If k equal to 0, then what happened? If k equal to 0, then this is exist or not? If k equal to 0, option 1 says that if k is equal to 0. So if k is equal to 0, then uxt, this is equal to y by 1. Yes, this is exist. Okay, we have to find the values of k such that the following problem has a solution. Okay, now if k equal to 4, k equal to minus 2. So if k equal to minus 2, then the value of u xt, this is equal to minus 2x plus y by minus 2y plus 1. Okay, and the interval is given that defined on 0 infinity. So defined होना होगा इस solution क्रॉस 0 infinity में, this region में. But if this value of y should take, I should take as minus half. If here, if we take y equal to only half, then this belongs to obviously 0 infinity and this becomes infinity. Okay, because this is the denominator term goes to 0 if we take y equal to half. Since half belongs to this interval and we have to define the solution in this interval. Okay, so that means this option is not true. Option C, option 3 says that if k equal to 4, if k equal to 4, then uxt, this is equal to what? K equal to 4. So 4x plus y by this is 4y plus 1. Okay, 4y plus 1. Okay, fine. So see, this is defined or not? This is not defined when 4y 4y plus 1 equal to 0, not defined on this interval. If this 4y plus 1 equal to 0, that is y equal to minus 1 by 4. But we have to define in this interval, and minus 1 by 4 does not belongs to 0 infinity. That is, this is completely defined in this interval 0 infinity. That is, this option is also correct option. So this is incorrect, this is correct. Now if we take k equal to 1, okay, if we take, so this is a very good analysis, you need to solve this problem. Okay, if k equal to 1, then u equal to what? U equal to x plus y by y plus 1, x plus 1 by y plus 1. Okay, now I think, yeah, so y plus 1, this denominator is 0 when this u is not defined. If this denominator is 0, okay, that is y equal to, for y equal to minus 1, this is not defined, but y equal to minus 1 does not in this interval, is not lie in the interval 0 1. So that means this is also a solution. That is, for these three values of k, 0, 4 and 1, the solution is defined. Okay, I think you should understand this problem very there is a very good analysis in this problem, these 4 options. Okay, so if you like this, or if you understand this problem, then obviously give a like to this video. Now going to the next question and today's last questions, which is the question ID is, just a second, 704095. Okay, so this question says that b equal to an interval given b equal to x y belongs to R2 such that x square plus y square less than 1. Fine, and be an open unit disk in R2. Okay, delta b is the boundary, delta b equal to xy belongs to R2 such that x square plus y square equal to 1 unit circular boundary, and b bar equal to given b union delta b, that is what? B union delta b for lambda belongs to 0 infinity. B union delta b means what? X square plus y square less equal to 1. Okay, So for B bar, let S lambda be the set of twice continuously differentiable function in B, then that are continuous on B bar satisfy the PD del u del x whole square plus lambda into del u del y whole square, this is equal to 1 in B. Then ux lambda uxy equal to 0 on delta B. Okay, then which are the following is true? S1 equal to phi, S2 equal to phi. S1 has exactly one element and S2 has exactly two element, and S1 and S2 both are infinite. That is, we have S2 both are infinite. That is, we have to find the cardinality of S lambda. Okay, so S lambda is the set of twice continuously differentiable function in B. That means we have to find the cardinality, that is number of solutions exist in this interval or on this interval. Okay, now this is a easy problem if you understand this problem, because these types of problems it also comes in the exam, in the past exams. How can we solve this problem? See, the important thing is this one, B bar equal to B union delta B bar and uxy equal to 0 on delta B. So if we see this line, then you can go a previous year problem, I think 2014 या फिर 15 में आता, I think मेरे को ठीक से याद नहीं है. So how can we take the solution? So this is not the general types of problems in any standard PDE form. Okay, then how can you solve the problem? See, uxy equal to 0 on delta B, these lines tends us to take the solution or to seek the solution as in the form of uxy, this is equal to k into 1 minus x square minus y square. Okay, these types of solutions we already, these types of specific problem we solved previously, I think in the previous paper 2014 or 15. If we seek the solution, this one, then this problem is very easy. And how can you think about this solution? See, this line and this line, because this line says that the solution, that is 0 on the boundary, the unit boundary. So this is the only solution which satisfies the boundary condition here. Okay, if we put this uxy to the equation. Okay, now we put this equation to this equation number 1. This is the original PD. So ux equal to minus 2kx and uy equal to minus 2ky. Okay, I think 2kx and 2ky. Now if we put in the equation 1, then 1 becomes what? 4k square x square plus lambda into 4k square y square, this is equal to 1. So this implies what? K equal to what? So k equal to 1 by 2 root under of x square plus lambda y square. Okay, so this is the value of k. Okay, now the value of u what? So the value of u is equal to what? The value of k, 1 by 2 into root under x square plus lambda y square into 1 minus x square minus y square. Okay, so this is the value of u. Okay, now if lambda equal to 1, if we take or if we choose any value or specific value of lambda, now the s, because s lambda is the set twice continuously differentiable function, so if we choose, okay, lambda equal to 1 or lambda equal to 0, you can take. If we take lambda equal to 0, then what will happen? If we take lambda equal to 0, then what happen? U equal to 1 by 2x into 1 minus x square minus y square. So this will tends to 0 if we choose x tends to 0 or y tends to 0, because the denominator term is of higher degree. Okay, now if we choose lambda equal to 1, this is we can't say anything if we choose lambda equal to 1. Okay, so if we choose lambda equal to 1 or if lambda equal to 0, it is not any conclusion you have to get from lambda equal to 0. If we choose lambda equal to 1, then this should be u equal to 1 minus x square minus y square by 2 root under x square plus y square, and this is the degree 1 and this is the degree 2. Now if x tends to 0 and y tends to 0, then this tends to, just a minute, equal to this 1 minus x square minus y square. I think I am writing the correct one. Okay, there is no problem on lambda equal to 0. If lambda equal to 1, then this term goes to 1 by 2 root over x square plus y square minus, okay, minus what will happen, 1 by 2 into root over of x square plus y square. Okay, fine. So see, if we choose x tends to 0, y tends to 0, then this term goes to 0, no problem, but this term goes to infinity. Just this term goes to infinity. That means what? For lambda equal to 1, the S1, that is lambda equal to, sorry, lambda equal to 0 not needed, because we have to find S lambda. That is what we have in the option it is given S1 and S2. The option based on S1 and S2, that is if we have to choose lambda equal to 1 and lambda equal to 2. So for lambda equal to 1, this term goes to infinity. That is, there is no finite solution. So that means S1 equal to, what will happen? S1 equal to 5. That is, this is in the option 1, I think. Yeah, so option 1 is the correct one. Okay, now option 2, S2. So for lambda equal to 2, what will happen? For lambda equal to 2, again we get u equal to 1 by 2 root under x square plus 2y square, x square plus 2y square minus 1 by 2 into 1 by sorry, I think yeah, x square plus y square by this one, and 1 by terms, one terms is present, 1 by, okay, so 1 by 2 into root over x square plus 2y square. I think here also x square plus y square term present. So this term goes to 0 because the numerator term are of higher degree, and these terms, if we take x tends to 0 or y tends to 0, then this term goes to infinity. This term goes to infinity. That means S2 is also 5, because S2 is what? S2 is the set of twice continuously differentiable function, but this function or this function are not the twice continuously differentiable functions of x and y. So that means this S1 and S2 are both 5. So if S1, this is true, option 1 is, this is true, option 2. Option 3 says that S1 has exactly 1 element and S2 has exactly 2 element, but no, S1 and S2 both does not have any element. Okay, and so this is option 3. Option 3 is wrong, and option 4 says that S1 and S2 are both infinite. No, there is no such function. There is no so many functions of x and y which are twice continuously differentiable. Okay, so here in this problem, option 1 and option 2 are the correct answer. Okay, so these are the two correct answer. I think this questions is understandable. Okay, so if you understand these questions or the solutions procedure of these questions, then obviously give a like to this video, share with your friends, and don't forget to subscribe the channel. Okay, thank you, bye.